Hello everyone, welcome to the online course on manufacturing processes. I am Dr. Kishore Kumar, Assistant Professor in the Department of Mechanical Engineering. So today we'll take last class also we took some numerical based on allowances in casting. Today we have brought some numerical based on solidification time in casting, how to calculate solidification time. We have already discussed this in detail, how to calculate. We derived the formula for solidification time, and also we solved few numericals based on that. This topic is very important, especially if someone is preparing for a GATE exam or for some higher study someone is targeting. And that is the reason I have brought some more numerical, standard numerical, which were asked in previous GATE exam. So we'll take few numericals, we'll solve based on this so that the concept of this solidification time in casting will be more clear through this numerical. So we'll start with the numerical. So first numerical which has been taken is, actually this is meter per second square, and this is 9 to 10 to the 6. Okay. So we are starting with this numerical read. So with the solidification factor of this 0.97 into 10 to the 6 meter per second square. If this is the solidification factor, calculate the solidification time for a spherical casting of 200 mm diameter. So in this problem, this solidification factor is given, and what is given? The casting shape is given. It is a spherical shape casting, and its diameter is given. It is 200 mm. So what we have to calculate? We have to calculate what will be the solidification time. If you remember, as in the last lecture, we have already discussed about solidification time. So solidification time is nothing but this is equal to this solidification factor, which completely depends on the material, what kind of material we are going to cast, into volume upon surface area of the casting. Okay, and volume upon surface area is also known as modulus of the casting. So if we'll write in terms of modulus, so we can write this solidification factor gamma into this modulus, this square of this one, so a square of this one. Here in the problem, it is given that the shape which we have to cast is actually sphere, that is a spherical shape. Okay, and its diameter is given. So if we have to calculate the modulus means volume upon surface area of the sphere. So it will comes out d upon 6, where d is the diameter of this spherical shape casting, and d is the spherical shape casting, that is the diameter. So in this problem, diameter is given. So if we'll put this one in this equation, so it will comes out solidification time T is equal to the solidification factor gamma into a square of this modulus, that is m square. So this will be equal to T is equal to, if we'll put the value, so this solidification factor is given 0.97 into 10 to the 6, and then into this modulus value is d upon 6, a square of this one, where d is the diameter of the spherical casting. So we can write here 0.97 into 10 to the 6, and d is 200 mm. So we can write 200 into 10 to the minus 3 divided by 6, and a square of this one, because this 200 is in mm, and this has been given in SI unit. So that's why we have converted this one in SI unit. Okay, so after that, what it will be 0.97 into 10 to the 6, and this will be 100, and this will be 3. So it will be 100 into 10 to the minus 3 divided by 3, this whole square. So this will be 10 to the 2, 10 to the minus 3, so it will be 10 to the minus 1 upon 3. If we will calculate this one, so finally we will get the value 1077.7 in second. It will be second. So that will be the answer of this one. So we can see from this numerical, nothing is there. If we know the formula means, and this was asked in GATE exam, previous GATE asked problems. Exactly year, I don't remember in which year it was asked, but this is actually in gate problem, previous year gate problem. Okay. So we'll take the next numerical, which also will be based on this page was intentionally left blank so that if something else we have to discuss, we will discuss. Okay. So this is the second numerical which I have taken based on this one, the solidification time calculation only. And it is a good question. This is also a previous year asked gate question. Previous year asked gate question. Okay. So what the problem is, calculate the ratio of solidification time. Ratio of solidification time of cylindrical casting in which the height is equal to radius. Height is equal to radius to that of a cubical casting of side 2 times the height of the cylinder. Okay. So what we have to calculate? We have to calculate solidification time, ratio of solidification time of cylindrical casting upon this solidification time of this cubical casting. So Cu we can write. So this one we have to calculate. What is given in the case of cylinder, it is given that height is equal to, if h is the height, so height is equal to radius. Okay. And in second one, cubical casting, it has been given that the side in cubical casting of side 2 times the height of, means the side is 2 times equal to the height of the cylinder. So these two information is given. Based on that we have to calculate this value. So first of all, we'll calculate what will be the solidification time of the cylinder. So we know the formula. What will be the solidification time of cylinder? So this solidification time will be some gamma, means that solidification factor, and a square of this modulus. Okay. So modulus will be volume upon surface area. So we need to calculate volume and surface area. So first separately we'll calculate volume and surface area. So what will be the volume of cylinder? This will be equal to pi r square h. We already know this one, and as here it is given that h is equal to r, so in terms of r we can write pi r cube. What will be the surface area of the cylinder? Surface area of the cylinder, this will be 2 pi r square h, 2 pi 2 pi r square, 2 circular section, one on the top and one at the bottom, plus 2 pi rh, area of the curved part. So this one we can write 2 pi r square plus 2 pi, and r and s both are equal. So in terms of r we can write 2 pi r square. So this will be simply 4 pi r square. If we will take the ratio, means volume upon surface in this case, so what will be m? M will be simply volume upon this surface area. So volume is pi r cube divided by this 4 pi r square. So pi, this will be cancelled out. So pi, this will be cancelled out, and this r square and this r, so it will be simply r by 4. Now we will take second case. What is the second one? It is a cubical casting. So in the case of cube, we know modulus is equal to side length upon 6, and this side length in the problem is given, it is twice of the height of the cylinder. You can see here it is clearly given at 2 times the height of the cylinder. So you can write this one 2h upon 6. So this will be 3. So it is h upon 3. And here it is r by 4. So as r is equal to h, so in terms of h we can write h upon 4. So what will be the ratio of solidification time of cylinder and this cube? So we can write solidification time of cylinder upon solidification time of cube. We can write what is the solidification time of cylinder? It is h by 4. So we can write h by 4 upon this h by 3 square of this one time, sorry, this 2 will be cancelled out, this solidification factor will be cancelled out, because material of the cylinder and material of the cube both are same. So as we know that this solidification factor depends on the material, so in the both casting, whether it is cylinder or in the case of cube, both will be same, so it will be cancelled out. So if we'll take this one, it will be cancelled out, so this 3 will go in numerator, so it will be 9 upon 16. So this will be the answer. Answer means this will be the ratio of the solidification time of the cylinder to the solidification time of the cubical safe casting. So in this numerical, nothing is there. Only thing is we have to remember two things. What is the formula for the solidification time, as well as we have to also remember, keep in our mind that solidification time is, or solidification factor is nothing but a material property. It depends only on the material, what kind of material we are going to cast. That's why it will be cancelled out, it will be common. Okay. So next we will take the third numerical. This is also previous year asked great question. Here, gate asked question. Similar to this in the previous lecture, when we were discussing the solidification time in casting, we have solved one numerical exactly of same, but there some values were not given. Here everything is almost given, so we'll solve this one, and we'll try to clear the concept that we studied over there through this numerical. This will be the last for the today's lecture. So what this numerical reads: 2 cubical casting of same materials. 2 cubical casting means shape of both the casting are same, both is cubic shaped, okay, of same material. Material is also same, so obviously if material is same, so their solidification factor will also be same. And sizes 2 centimeter side and 4 centimeter side are molded in green sand. Okay, so one side length of the cube for the first casting is 2 centimeter, and for the second casting is 4 centimeter. It is given. Okay. If the smaller casting solidify in 2 minutes, means out of these two, a smaller one means first one, this 2 centimeter side. If it takes 2 minutes for solidification, we have to calculate how much time the second one will take for the solidification. Okay. So simply we'll apply the formula, solidification time formula. So if we'll write T2 for the second casting solidification time upon T1 solidification time of the first casting, so we can write volume upon surface area of the second one, square of this one, to volume upon surface area of the first casting to the square of this one. Okay. Now we'll put the value. Already we know that in the case of cube, this will volume upon surface area is nothing but side length. So if we are writing A2 side length for the second casting, so it will be A2 upon 6. And for the first one, if we are writing A1 for the side length, so it will be A1 upon 6 and a square of a whole. Okay, so these 6 and 6 will be cancelled out, and it will finally will be A2 upon A1 whole square. So what is A2? In the problem it is given, so we can write from here A2 is 4 and this is 2, a square of this one. So this is 2, 2 square is equal to 4. So what we got finally, we got solidification time of the second casting upon solidification time of the first one is equal to 4. This implies solidification time of the second one is equal to solidification time of the first one into 4, and solidification time of the first one is given in the problem. It is 2 minutes. So this will be 2 into 4. So it will be 8 minutes. So T2 is equal to 8 minutes. Means the second casting will take 8 minutes for complete solidification. Okay. So that's all for the today's lecture. Next lecture will come up with some new interesting topic. Thank you for listening the lecture. Thank you.